All right, let's jump right into this explainer. Today, we're taking a really fascinating journey. We're going to bridge the foundational, academic concepts of big data, those bedrock principles that started this whole thing years ago, with the explosive, almost sci-fi reality of artificial intelligence in 2026. If you've ever found yourself wondering how the massive digital footprints we leave behind every single day are actively powering the autonomous systems of tomorrow, well, you're in exactly the right place.
So here is our roadmap for today. We'll be hitting 1. Introduction to big data. 2. The V's of big data. 3. The 2026 data explosion. 4. Why AI needs big data. 5. Modern big data architectures. And finally, 6. The future of analytics.
Section 1. Introduction to big data. Let's lay the groundwork with the core concepts that started it all.
At its core, and this is going by early encyclopedias and standard ChatGPT definitions, big data simply refers to data sets that are so massive, so complex, you literally cannot open them on a standard computer without the whole system crashing. Think about it. Have you ever tried to load a massive file into a basic spreadsheet and your computer just completely freezes up? Or maybe downloading a cloud dataset would take a full week? If so, congratulations, you are dealing with big data. It's essentially the point where traditional processing tools just throw their hands up in defeat.
To give you some context on the foundational scale we used to deal with, organizations like the New York Stock Exchange were generating a terabyte of trade data every single day. And Facebook was hosting around 10 billion photos, taking up an entire petabyte of storage. Back then, that was absolutely mind-blowing. Today, honestly, a family group chat feels like it generates that much in a week. But seriously, as you'll see in a minute, what was considered massive back in those early days is just a tiny drop in the bucket today.
Moving on to Section 2, the V's of big data.
Now, what's really interesting here is how data scientists historically categorized all this information. We have these 3 core dimensions known as the foundational 3 V's. First up, volume. That's just the sheer physical size, all those terabytes and petabytes. Then we have velocity, which is the speed at which data streams in, evolving from slow overnight batches to near real-time pipelines. And finally, variety. This means data isn't just neat little rows and columns in a database anymore. It's unstructured text, it's sensor logs, images, you name it.
But here's the crucial point. As the industry matured, those 3 V's had to evolve into the 5 V's. Because, think about it, having a mountain of incredibly fast, highly varied data is totally useless if it's full of garbage, right? So they added veracity to ensure trustworthiness and authenticity. And perhaps most importantly, they added value. Because at the end of the day, if you aren't extracting real, actionable business insights from this massive infrastructure, well, it's really just a giant technical burden.
All right, Section 3, the 2026 data explosion.
So let's jump forward to today, and we need to completely shatter those old boundaries of scale. Look at this massive contrast. On the left, in a 2011 industry report, a data analyst actually bragged, "We don't count terabytes, we count records." They were absolutely thrilled to be handling a few billion records. Fast forward to 2026 on the right, and large-scale enterprises consider managing 5 to 10 petabytes as just baseline normal. And globally, the total data universe is projected to exceed 221 zettabytes. To put just one single zettabyte into perspective, if every gigabyte were a brick, you could build the Great Wall of China hundreds of times over. No joke.
We're riding this staggering exponential rocket ship of data generation. We've got billions of IoT devices, smart factories, augmented reality platforms, all generating continuous, endless streams of data. It makes the manual batch processing of a decade ago look like the Stone Age. Honestly, if you aren't processing your data in real time today, you're already behind.
Which brings us to Section 4, why AI needs big data.
This is the central question of our explainer. How do AI and big data operate in this perfect, almost biological symbiosis? This quote really hits the nail on the head. Data is no longer just sitting in some cold back-end storage. It is literally the fuel for the AI engine. Here's why this matters so much for us. Modern artificial intelligence, especially generative models and deep learning, is strictly only as good as the information feeding it. You could have the most advanced, brilliant algorithm on the planet, but without massive amounts of big data, those AI models simply will not work.
Let's look at how this builds a really brilliant, continuous feedback loop. Step 1. Vast amounts of data are generated, and keep in mind, 80 to 90% of this is unstructured stuff like text and video. Step 2. This big data acts as the massive training ground for our AI models. Step 3.
The AI digests all of this and identifies hidden, complex patterns that human eyes would literally never catch. And then step 4. This is the beautiful twist. The AI actually turns around and optimizes the very data pipelines that feed it. It catches anomalies, adjusts flows on the fly. They absolutely need each other to survive.
Section 5. Modern Big Data Architectures. Let's look at how we actually handle all of this.
To manage this massive AI-driven feedback loop without a total system collapse, we have to look at how data is architected in 2026. Enter the open lakehouse. A data lakehouse is exactly what it sounds like. It takes the massive, cheap, unstructured storage capabilities of a data lake and combines it with the highly organized, lightning-fast performance of a data warehouse. Whether a company uses Apache Iceberg, Delta Lake, or Apache Hudi, these formats create a solid, resilient foundation, so your AI doesn't just drown in a swamp of messy data.
And finally, Section 6, the future of analytics.
As we look at the horizon, this raw computing power leads us to a pretty profound shift in the workplace. With platforms becoming more and more autonomous and a global IT skills gap threatening trillions in lost opportunities, we have to ask the elephant in the room question: are human analysts being completely replaced by machines?
Well, the answer isn't a simple replacement. It's what we call an agentic paradigm shift. Instead of humans sitting there manually typing queries into databases all day, 2026 introduces agentic AI. Think of these as autonomous digital workers. We're now seeing multi-agent systems where specialized AI agents, like say one monitoring global weather, one tracking inventory, and another handling logistics, actually collaborate with each other in real time to completely reroute a supply chain totally without human intervention. They don't sit around waiting for a human prompt. They actively monitor streams, they detect anomalies, and they execute actions while just leaving a transparent audit trail for us humans to supervise. It is genuinely awe-inspiring how far we've come from basic crashing spreadsheets.
Which leaves us with this final thought. The stakes right now are incredibly clear. Companies that are leveraging these AI and big data trends are reporting massively higher productivity, while those relying on old, manual batch processing methods are facing a serious existential threat to their survival. So, as you process these massive shifts, consider this. Is your organization treating data as a strategic, mission-critical asset to fuel this autonomous future? Or is it just a technical burden tying you to the past? The era of big data experimentationism? Yeah, that's over. The era of autonomous intelligence has officially arrived. Thanks so much for joining me on this explainer, and I will catch you in the next one.